Hello, my name is Jeremy Steed. I'll be picking up where David left off and talking about the effects on the industry of the Davis-Besse incident. The Davis-Besse incident has several profound impacts on the nuclear industry um, and led to many improvements by the NRC. Um, this incident required the nuclear power industry, and in particular the NRC, to take a deeper look at the safety atmosphere, attitude, and procedures at nuclear power plants and within the NRC. From a procedural standpoint, the most immediate concern for the NRC and Davis-Besse was to determine why previous inspections by Davis-Besse and the NRC did not lead to the discovery of the degradation sooner, and if this is occurring at other plants. The stress corrosion cracking issue was one that needed to be addressed at each plant that was susceptible to reactor pressure vessel head degradation. And in these plants, the NRC ordered them to visually inspect the reactor vessel head surface area for indications of leakage and boric acid accumulation. They also ordered them to inspect head penetrations using non-destructive methods to detect cracks before leakage starts. The NRC also worked with the American Society of Mechanical Engineers to incorporate long-term inspection requirements into the ASME code. These concerns also led the NRC to form the Davis-Besse Lessons Learned Task Force. This was the most important instrument in driving improvements in the nuclear industry from the Davis-Besse incident. The purpose of the Lessons Learned Task Force was to conduct an independent evaluation of the NRC's regulatory processes related to assuring reactor vessel head integrity. They were to identify and recommend areas of improvement applicable to the NRC and the industry. There were three general conclusions of the investigation launched by the Lessons Learned Task Force that led to 51 recommendations for improvement to the NRC. The first conclusion was that Davis-Besse failed to ensure plant safety issues received appropriate attention. The investigation specifically stated that good safety culture characteristics were not clearly evident at the Davis-Besse plant. This was a great concern since the safety is paramount in the nuclear power industry. The NRC describes safety culture as the core values and behaviors resulting from a collective commitment by leaders and individuals to emphasize safety over competing goals to ensure protection of people and the environment. A healthy safety culture also includes the concept of having a safety conscious work environment. The safety conscious work environment is a work environment where employees are encouraged to raise safety concerns and where concerns are promptly reviewed, given the proper priority based on their potential safety significance, and appropriately resolved with timely feedback to the originator of the concern and to other employees as appropriate. A nuclear plant with a safety conscious work environment gives employees and managers the freedom to raise concerns without fear of retribution. A poor safety culture in general and safety conscious working environment in particular are the background causes of the incident at the Davis-Besse plant. The report indicated five major issues with the safety culture. First, although safety is a recognized value in the organization, is inconsistently accepted and understood across all levels of personnel. Second is accountability and ownership for safety are not yet universally accepted in the organization. The third is safety is not yet consistently integrated into all activities in the organization. The fourth, an integrated and cohesive organizational safety leadership process does not yet exist. And the fifth is safety is not learning driven at the Davis-Besse plant. In response to these issues with safety culture and safety conscious work environment, the Institute of Nuclear Power Operations and the NRC developed further guidelines on how to have a strong safety culture and safety conscious work environment and made it a major concern for all nuclear plants. The NRC took significant steps within the reactor oversight process to strengthen their ability to detect a weak safety culture in inspections and performance assessments. The second conclusion was that Davis-Besse, the nuclear industry, and the NRC had not adequately reviewed relevant operating experience at other nuclear power plants. This led to new regulations by the NRC on how to handle operating experience and the development of a new organization within the NRC named the Reactor Operating Experience Program. The Reactor Operating Experience Program is designed to act as a clearinghouse for operating experience in the nuclear industry. The function of the Reactor Operating Experience Program is to collect, communicate, and evaluate operating experience, foreign and domestic, and apply the lessons to the core regulatory functions of oversight, licensing, rulemaking, and incident response. This organization has daily screening meetings to review incoming event reports and other operating experience items. The information that's collected and reviewed can be accessed by internal users and members of the public through a single web access page. This provided a central location for submittal and retrieval of incidents and problems throughout the industry. Along with the Reactor Operating Experience Program, the NRC established new and revised regulations with regard to the duration of a licensing project manager assignment to a specific plant, the frequency of site visits, communication with the resident inspector staff, and maintenance of a questioning safety attitude about plant events to ensure plant experience is adequately considered in licensing decisions. The last result was that the NRC's assessment of Davis-Besse's safety performance did not consider all available information. The NRC did not scrutinize the Davis-Besse plant and made less frequent inspections because they had a high safety rating at the plant. This led to a complacency when considering actions at the plant. Another improvement from the NRC was to the process for inspections on components susceptible to primary water stress corrosion cracking. The improvements improved, the new requirements improved how both plant operators and NRC inspectors perform the inspection process. The NRC staff made several changes to the inspection process to enhance their ability to detect declining plant performance, including the specific issues that identified at Davis-Besse. There was an evident need for this change after investigation of the event indicated the deteriorating condition had been underway for several years and that the planned inspection, maintenance, and modification activities that could have prevented or enabled earlier discovery of the condition were frequently deferred. As David mentioned, the improvements to the Davis-Besse plant required by the NRC before they could return to operation took 2 years. Everything with the plant seemed fine until in 2010, when there were boric acid deposits discovered on the reactor vessel head once again during a required inspection during the 16th refueling outage. It was determined that the boric acid had not compromised the structural integrity of the reactor pressure vessel head through non-destructive evaluation. The flaws were consistent with primary water stress corrosion cracking, although its onset was unusually rapid since the reactor vessel head had been replaced since the 2002 incident. The early development of this primary water stress corrosion cracking is largely attributed to the vessel head temperature being slightly higher than expected during the most recent operating cycle, and also likely poor material microstructure. The NRC commissioned a special inspection team to independently assess the licensee's evaluation of the CRDM nozzle flaws and safety analysis. They concluded that Davis-Besse actions met NRC requirements and that the vessel head was in a suitable condition to return to service. However, the NRC also decided that Davis-Besse had to replace the head again in 2011. The Davis-Besse incident is one that should be looked at by the entire industry and studied on a regular basis. It shows what could potentially occur when you either put production above safety or do not have sufficient questioning attitude or sense of urgency when you see something unexpected. The Davis-Besse plant was 1/4 of an inch of stainless steel away from an unisolable leak of the reactor. and catastrophe for the plant and the entire industry. The NRC made many improvements in an effort to keep this from occurring, but the individual plant safety cultures are the greatest weapon the industry has in fighting potential catastrophes. That is all that we have for the Davis-Besse incident. I hope that you learned a lot, and that you will take this incident with you in the future as a reminder of the things that we need to do.